Hello guys. So now we will see this question. A line AB 100 long is inclined to HP at 30 degree and VP at 45 degree. A point A is in front of VP by 10 and above HP by 25 Draw projection of line. So here true length is 100 theta is 30 degree, phi is 45 degree. The point A is below XY line by 10 as it is in front of VP. So we will take this point below XY line, and the point A is above HP by 25 So we will take point XY above XY line by 25 So first we will draw XY line, then we will take scale perpendicular to XY line and mark 2.5 centimeter, that is 25 this point on this line, and 1 centimeter on this line below XY line. We will mark this point A dash here and small a here. So this area is for front view, this area is for top view. After marking this point, we will draw a baseline which is parallel to XY line, baseline in front view and baseline in top view. Then as a line is inclined to HP at 30 degree, so in front view this angle will be 30 degree. This angle is theta is 30 degree, and the line is inclined to VP at 45 degree, so this angle will be 45 degree. It is taken from this point with reference to baseline. The length of this line is 100 10 centimeter. Okay. So as we have discussed in previous video that the projection of true length on opposite side baseline is a projection. This will be plane length. Okay. So line parallel to this projector 1. So this line is a projector 1. The line which is passing through the starting point in front view and top view will be projector 1, and line parallel to projector 1 we will take projections from with reference to projector 1. Okay. So from this point, so this point is the end point of true length in front view. So mark this point as B1 dash and mark this point as B2. Okay. So from B1 dash draw projection of this point up to baseline in top view. So this length will be plane length without inclination, and also this is a true length. This length is 100 and projection of point B2 up to baseline in front view will be, so this length will be elevation length. This length is a elevation length, this length is a plane length. Okay. So as per theory of projection, there is a locus line which is parallel to XY passing through end point of true length. As we have known the end point of true length here, because point A dash is fixed, it is 25 above XY line, that is it is 25 above HP, and angle is 30 degree, length is 100 So this end point is fixed. As end point is fixed, we can draw a locus line parallel to XY passing through point B1 dash. So this point will be locus line. Also B2 point is also fixed. So we can draw locus line parallel to XY from this point. So this will be here locus in front view and locus in top view. Now, as per theory of projection, the end point of plane length will lie on locus in top view. So, see the projection of 100 mm here, this length will be true length sine of cos of 30. Okay, so PL will be true length cos of theta, that is cos of 30, and elevation length will be true length cos of 45. So plan length is TL cos of 30, 100 cos of 30 is root 3 by 2, 100 into root 3 by 2, and elevation length is true length. So elevation length, this distance is equal to true length cos of 45. True length cos of 5, 100 into cos of 45 is equal to 1 by root 2. Okay. So as we know that end point of plan length, this is plan length end point, this is plan length starting point, but this is only length, but line is lie on the end point of this plan length will lie on locus in top view as per theory of projection, right? So we will draw arc from this point up to locus line. So this point is end point of plan length, and this point, so this is end point of elevation, this is elevation length, and end point of elevation length lie on locus line. So we will draw arc up to locus line in front view, and this point will be end point of elevation length. This is elevation length and this is plan length. So as per trigonometry, plan length will be 100 into root 3 by 2. This is equal to 86.60 mm. And if we calculate it by scale, then it will be 86 mm. Elevation length here, if we measure by scale, it is 70 mm, and as per trigonometry, it is equal to 70.71 mm. So which is nearly equal. So this is our answer. Now we can measure this angle. This angle in front view is alpha. Alpha is equal to 46 degree. So alpha is 46 degree, beta is 55 degree. So this is final answer. The projector 2 is this line is a projector 1, and the end point of elevation length and end point of plan length, if we connect these 2 points, then this will be the projector 2. The projector 2 and projector 1 are parallel, always parallel. Okay, so these also projector 1 and projector 2 are parallel. Locus line is always parallel to xy line. Locus line on both sides are always parallel to xy line. Then projection of true length, end point of true length. Then alpha is alpha and beta are apparent angle, and theta and phi are true angles. Alpha here is 46 degree, beta is 55 degree, theta is 30 degree, and phi is 45 degree. So these are true angles, true inclination of line, true inclination of line, and these are apparent inclination. So alpha is apparent inclination of elevation length. Okay, so alpha is always greater than theta, right? So in front view there are two angles, theta and alpha. Alpha will be always greater than theta, and in top view there are two angles, phi and beta. So beta, this is apparent inclination, will be always greater than phi. So these are the common observations. By analyzing these common observations, we will solve other types of problem. This is a basic type of projection of line of problem.